Okay, momentum, or pMomentum as I like to call it. pMomentum is represented by the letter P. A lowercase p, even though you can't really tell it's lowercase, momentum is represented by a lowercase p. Momentum is equal to mass times velocity. So the m is mass, the v is velocity. Okay, what do you think? Do you think momentum is a scalar or a vector? Hopefully you're headed in the right direction. Momentum is a vector.
So momentum has a direction. You can have positive or negative momentum depending on which way your velocity is pointed.
What are the units of momentum? The units of momentum, well, let's look at the definition of momentum. Momentum is a mass times a velocity. So what are the units of mass? Mass is measured in kilograms. What is velocity measured in? Meters per second. So momentum is a kilogram times a meter over seconds. The units of momentum are kilogram meters per second. Kilogram meters on the top, seconds on the bottom. So because momentum is a vector, we give the p a vector hat and the v a vector hat. Because momentum is a vector, velocity is a vector. And again, momentum is inertia for moving stuff. So if an object that has mass is moving with a certain velocity, it has momentum. Not only does it have inertia because it has a mass, but it also has momentum because it's moving. So because it has momentum, it is going to resist changing its motion. Okay, the more momentum you have, the more resistance you have to a change in motion. So the total momentum of a system is always conserved. It's always going to stay the same if there's no outside forces. So if there are multiple objects in a system, the momentum can be transferred between the objects, but the total momentum of all of the objects in a system is always conserved. It will always stay the same. How do we write this in terms of variables? Momentum is represented by the letter P. So we can say that the momentum at the beginning is equal to the momentum at the end. What's another way to write beginning for a subscript instead of having to write out beginning all the time? I can write P naught. The initial momentum of the system is equal to the final momentum of the system, and I'm going to write an F subscript for final. So if there are no outside forces, the initial momentum, the momentum at the beginning, is equal to the final momentum, or the momentum at the end. So there's two types of collisions, elastic and inelastic. It's very important that when you see a collision that you are able to determine whether it is elastic or inelastic. If a free response question has to do with momentum or a collision, you will most definitely get points for identifying whether it's an elastic or inelastic collision. And you also need to identify whether a collision is elastic or inelastic so that you solve the problem correctly. So how do you tell what kind of a collision that you have? So when you're reading a problem, there are certain words that should spark your thoughts towards momentum, towards collision, and towards which type of collision that you're talking about. So in a problem, if you see the word collision, you should automatically be thinking momentum. If you see the word collision in the problem, think momentum. If in the problem you see the word bounce, if you see the word bounce, you should automatically be thinking elastic collision, and it means that the objects after the collision are going to separate. If, on the other hand, you see the words stick together, then your mind should automatically think inelastic collision. Sticking together means that after the collision, the objects that collide are going to stay together. They're going to stick together, which is what an inelastic collision is. Now, in both types of collisions, elastic and inelastic, momentum of the system is always conserved. Now, what about energy? Is energy conserved? So when we're talking about collisions, we're talking about momentum, and because we have moving stuff, we're going to be talking about kinetic energy. In an elastic collision, kinetic energy is conserved. The kinetic energy before the collision is equal to the kinetic energy after the collision. However, in an inelastic collision, kinetic energy is not conserved. The kinetic energy before the collision does not equal the kinetic energy after the collision. Where does that energy go? That energy becomes some other form of energy. Energy is still conserved. We're not violating conservation of energy. That's still always true. The kinetic energy is not conserved, meaning the kinetic energy becomes some other form of energy, like heat energy, for instance. In both types of collisions, momentum of the system is conserved. So the total momentum of the system before the collision is equal to the total momentum of the system after the collision. So this statement here is true for both elastic and inelastic collisions. Now let's break this down into variables. So let's say you have two objects that are colliding. In the first case, let's say they are going to experience an elastic collision. The total momentum of the system before the collision. To get the total momentum of the system, I have to add up the momentum of each of the individual parts of the system. So if I have two objects in the system, I have to add the initial momentum of the first object, or p01. So remember, the naught represents initial. 1 is to identify the first object. Momentum is represented by p. So p01 is the initial momentum of the first object plus the initial momentum of the second object. By adding these two together, the initial momentum of each of the objects before the collision, I get the total momentum of the system before the collision. Now that is equal to the total momentum of the system after the collision. To get the total momentum of the system after the collision, I again need to add the final momentum of each of the objects
in the system.
So P1 plus P2. Remember, the not represented initial momentum. Now I just have P1 and P2 for final momentum. Now let's break this down further. Remember, momentum is mass times velocity. P01, the initial momentum of object 1, can be written as m1, the mass of object 1, times v01, or the initial velocity of object 1, plus m2, mass of object 2, times the initial velocity of object 2. So remember, momentum is mass times velocity. Initial momentum of object 2 is m2, mass of object 2, times the initial velocity of object 2. That is all equal to the final momentum of object 1 plus the final momentum of object 2. So how can I break the final momentum of object 1? Well, it's still m1 times its final velocity, which I'm going to call v1. And now I need to add the final momentum of the second object, which is going to be m2 times the final speed or final velocity of object 2. If you are dealing with an elastic collision, this is going to be the equation that you're going to use. What about inelastic collision? So for an inelastic collision, this statement is still true. The momentum of the two objects at the beginning, the initial momentum of the system is equal to the sum, or adding the momenta of each of the individual objects in the system. And that's equal to the total momentum of the system after the collision. Okay, Now here's where the difference is between elastic and inelastic collisions. So the first part stays the same as for elastic collisions. So the initial momentum of object 1 is going to be m1 v01, mass of object 1 times initial velocity of object 1 plus m2, mass of object 2 times the initial velocity of object 2. That's equal to, okay, this is the key part. Remember, in an inelastic collision, objects stick together. What does that mean? If two objects collide and then they stick together, they are going to be moving together with the same speed. So both of the objects are going to be moving together with the same speed after the collision. So instead of writing them out individually, the final momentum of each object, both the first and the second object are going to be moving together with a shared speed, v final. I'm going to call it v final. Here's the difference between elastic and inelastic. After an inelastic collision, the objects are going to stick together, m1 and m2 are going to stick together and move together with the same final speed. In an elastic collision, they might have different speeds at the end, but because they stick together in an inelastic collision, they're going to have a shared final speed. So that is how we write this out. Okay, so if you have an inelastic collision, this is going to be the equation that you use. The biggest tip I can give you when solving momentum and collision problems is to use your subscripts. Please, please, please write out all of these subscripts so that you can tell them apart. It's not an easy thing to do, to keep track of all of these different things, right? So please take the extra time to write out all of these subscripts on each of your variables so that when you're solving, you know where and what to plug into your equation. And when you're labeling your knowns for your problem in a momentum/collision problem, make sure you use those subscripts so you know where to plug them in. This is where subscripts are super, super, super important because it'll be very confusing if you don't use them.